Here we have example number 4. This is a bit of a real-world problem where we're having to use a dilution calculation or a type of dilution calculation to solve a problem. So we have a lab analyzes a urine sample to determine the concentration of sodium chloride in the patient's urine. A 10 ml aliquot, and the word aliquot is a scientific word for sample. So a 10 ml sample of urine has been diluted to prepare a 50 ml solution, and the diluted solution is found to have a concentration of 0.200 moles per liter sodium chloride. What was the concentration of sodium chloride in the original concentrated sample? This is an interesting question because, generally speaking, with dilution calculations, we're often asked to find the concentration in the diluted solution, or C2. And here, we're actually going the other way, and we're being asked what was the original concentration of the more concentrated solution. So we're actually looking for C1 in this question. That is our unknown variable that we're solving for. We know it's a dilution because the question states that we're performing a dilution. So we can go ahead and use our formula C1V1 equals C2V2. And before we get going, we should identify which variables we have in our question. I'm going to write them off to the side because this question is a little bit more wordy. It's got a lot of information. So let's unpack it a little bit. Let's start with let's figure out, we're looking for C1, that's the one we don't know. Well, what's C2? What was the final concentration after the dilution? Well, the question tells us after the dilution, the concentration of the solution was 0.200 moles per liter. So there's our C2. It's the only other concentration in the question. Okay, and our volumes that we're going to need are going to be V1 and V2. Well, what was the volume of the initial concentrated sample? And the answer is 10 milliliters. We took a 10 ml sample of the concentrated urine. So the V1 is 10.0 mils. Okay. And after the dilution, what was the volume? Well, the question tells us it's been diluted to prepare a 50 ml solution. So there's our V2. After the dilution, we had a total of 50 mils. All right, great. We've got everything we need now to plug this in. We're solving for C1, so let's rearrange this formula. I'm going to divide both sides by V1 so that I've got C1 on its own on the left-hand side. So C1, concentration of sodium chloride, originally is equal to C2, 0.200, keep my units in my calculation, times V2, be careful here, make sure we're using the right value. V2 is 50 mils, and I'm dividing by V1. My original volume was 10 mils. Okay, so when I do the math, my answer comes out to be 1. And I've got some zeros after that. Why do I have some zeros? Let's look at sig figs for a moment before we carry on. In each one of these values, C2, V2, and V1, I had 3 sig figs. All those values contain 3 sig figs. So my answer must also have 3 sig figs because I am limited to the least precise number of sig figs in my data. Since they all have 3, the answer has to have 3. So even if your calculator spits out a 1 with no decimal places, it's very important here that you report 2 decimal places after the 1. So 1.00 has 3 sig figs, and that is correct. And our units have to be in our answer as well. And this is a concentration, so my units are moles per liter. Coming back for a moment to my calculation, I forgot to cancel my milliliters, and that's a good habit to make sure I'm canceling out the units that are no longer there anymore, the ones that cancel. So my answer then is that the concentration of sodium chloride is equal to 1.00 moles per liter in the original urine sample.